Okay, so in this video we're talking about finding a polynomial that fits a given data table. So for instance, if we're given a table, then a polynomial that fits that table is going to have the degree of the polynomial So the degree of the polynomial will be will be at most one less than the number of points that are given in the data table. So for example, if there's 4 points in the data table, then the largest degree that that polynomial can have is going to be 3, or cubic. So to do this in your calculator, what you want to do is hit stat, and then enter the points in your data table. The input values, which are typically our x values, are going to go in list 1. The output values, which are typically our y values, are going to go in list 2. Then you want to hit the stat button on your calculator again and scroll over to the calculate menu. And then choose what type of regression you want to use. For instance, if you had 4 points in your data table, then at most you could have is a degree 3 cubic polynomial. So you would go to cubic regression. Let's do a few examples. So in table 1, we have 3 data points, so at most it could be a squared polynomial. So I'm going to go ahead and just pull my calculator. I suggest you follow along as well. But again, what you want to do is hit stat, go to edit, and I'm going to put my input values in L1, my output values in L2. So 2, 5, 7. Go over to L2, put in your outputs, 5, 11, 15. Again, since this had 3 points in it, at most it can be a quadratic. So I want to go to stat and scroll over to the calculate menu. And this time I'm going to go to quadratic regression, which is option 5 on my calculator. Just hit enter. And then what it does is it gives me a pattern. So here it tells me y equals ax squared plus bx plus c. And it populates some values for these different parameters. So my coefficient a is 0. So y equals ax squared plus bx plus c. I'm told from the calculator that a is 0, b is 2, and c is 1. And then what I can do is just clean this up and find the actual equation for this polynomial. So I have y equals 2x plus 1. So it actually turned out that even though I started off with a quadratic regression, I finished with a linear polynomial that fit this particular table. Let's go on to example 2. Notice that for all 3 of these tables, my input values are exactly the same. I just did that out of convenience. It's not going to always work out that way. So again, to do this over for table 2, I'm going to hit stat, go to edit. Again, my input values are already in there, so all I need to do this time is change my output values. So go to L2 and enter those in to 6, 30, and 56. Again, since there's 3 points in my table, then at most it can be a quadratic, it's degree 2. So I'm going to go to stat, calc, and again, option 5 for quadratic regression. So I'm just going to hit enter, and again it gives me the exact same pattern. So y equals ax squared plus bx plus c. A is 1, b is 1, and c is 0. So I can plug these parameters in for my coefficients and get the actual polynomial that fits this table. So I have y equals 1x squared plus 1x. Okay? So here I have a quadratic. Before, with the first data table, I only had a linear. I still knew at most it could be a quadratic polynomial that fit. Let's do it one more time just for extra practice again. The input values are exactly the same. I just need to change the output values. So again, one last time, stat, go to edit, changing the output values. So L2 is 10, 55, and 105. Again, there's only 3 data points in this particular table, so I know at most it has to be a degree 2 polynomial, which is a quadratic. So when I hit stat, go to calculate, I'm looking for quadratic regression. So option 5, hit enter, and here it gives me my pattern again. So y equals ax squared plus bx plus c. Again, my calculator tells me that a has to be 2, B has to be 1, and C has to be 0. So for this particular table, my polynomial that fits it is y equals 2x squared plus 1x. So even though the tables are the same, our polynomials are completely different. And that's it for this video.